Excellent. So to finish off this chapter, we're going to create another mini app, which is an app that will tell you whether a number is prime or not. Now, you may remember from your school days that a prime number is one that can be divided by precisely two numbers. That is 1 and itself. So, for example, 2 is a prime number because it can only be divisible by 2 and 1. 3 is also a prime number because it can only be divisible by 3 and 1. 4 is not because it can also be divisible by 2. 5 is, 6 isn't, 7 is, 8 isn't, 9 isn't, etc. So that's just a quick recap on prime numbers there for you. The reason I've decided to do this app at this stage is because the big chunk of code, the difficult bit of the app, actually doesn't really depend on any user interface elements at all. It's taking a number and working out whether or not it's prime. So that's a really good example of how we can use playgrounds to be able to build that bit of the app without having to check by running the app every time, which would slow us down. So what we're going to do is create the main chunk of code which will tell us whether or not a number is prime in the playground, and then in the next video we'll go on to create the user interface and actually create the app and how it works, and we'll be able to just copy and paste our code straight into that app. So that's a really good way to develop an app if you've got an app which does something quite major in the background that doesn't require access to user interface elements. So let's get on with it. We'll get rid of our code from the last video. Now, this is definitely something that you can do yourself. It might depend on how confident you are with maths a little bit, but all it is a couple of for loops or while loops, depending on which you prefer, and a few if statements. So I'd strongly recommend that you try and do this yourself completely and then only come back and watch me if you have problems. The first bit, of course, is going to be defining our number. So let's create a variable called number and let's initially set it to 5. So we know that 5 is a prime number and we want our program to return so, and then we can experiment a little bit and find out whether or not our program gives the right outcome for various different numbers. So start with that line and then pause the video and give it a go. Good luck. Right, I hope you managed it. It wasn't easy, but here we go. I'll show you at least my way of solving it. There's lots of different ways that you can do this, but I'll show you one. So what we want to do essentially is go take every number which is less than 5 and try and divide 5 by that number. And if we find a number that does divide into 5, then it's not prime. If we don't, then it is prime. So I'm going to start by assuming that my number is prime, and then I'll only change that if I find a number that goes into it, that divides into it exactly. So I'm going to create a variable called isPrime. Now you could use, say, 0 and 1 for this. So 1 meaning is prime and 0 meaning is not prime. But I will just introduce you to a new variable type, which I don't use very often personally, but it's quite handy. It's known as a Boolean, and it can be only true or false. And that's quite useful in this case because our isPrime is only going to be true or false. So that's a handy little new variable type for you as well. So we're going to want to run through all of the numbers less than 5 and to see if they divide into 5. So let's create a for loop to do that. So I equals, we're not going to start at 1 because 1 goes into every number. We're only interested in 2 or above. So we'll start with I is equal to 2. And then we want to keep going as long as I is less than our number. We don't want to go all the way up to our number because 5 always goes into 5 and 6 always goes into 6, etc. So we definitely want to keep it less than our number. If you're really into efficiency, you can actually make this a bit less. You can put number divided by 2 in there and all sorts of things. You can actually put the square root of the number if you're feeling very fancy, but I'm just going to leave it as less than number because that'll get the job done. And we want to increment I each time, so I++. So now in this line, we want to check whether our number, that is number, is divisible by I. Now, do you remember how to do that? We saw that a few videos ago. We use an if statement and we look at number percent I. And this, you'll remember, gives us the remainder when number is divided by I. So if that's equal to 0, then that means that it goes exactly. And if it goes exactly, then our number cannot have been prime. So we'll need to change is prime to false. And then once we've finished all that, for now, let's just print ln is prime. So in this case, we've got a true, which is great because 5 is prime. Let's pop a 6 in there and we should get a false. Aha, we're looking good. Let's try 15, which should be a false. It is. Excellent. So it looks like our code is doing what it should do. 19 is prime, so that's great. Now we will have a couple of slight problems though. Again, you might have anticipated these. What if we put 2 in there? 2 is a prime number because it only divides by itself and 1. And yet it's returned 2 because 2 does go into 2. So we need to actually treat 2 as a special case. It's a bit of a fudge, but it will do the job. We'll just say if number is not equal to 2, then run all this code. So then that will give us the correct result for 2 because we're just assuming that 2 is prime, which we know that it is. The other problem we're going to have is when I is 1. And you can see what's going to happen here. We start at 2, we keep adding 1 for I, but we're never going to get to number because 1 is less than our starting point 2. So we're going to need to treat 1 as a special case as well. And what we'll do is we'll say if number is equal to 1, then is prime is equal to false. Get that in the right place. There we go. And now we can put this code in here. So we'll avoid running this code if number is equal to 1 or 2. So that just allows us to treat 1 and 2 essentially as special cases. So when number is 1, we set is prime equal to false, and then we don't do any of the checking. And there we go. Not too bad. We can now check for 1, which works. 2 should give us true. 3 should give us true. 4 gives us false, etc. And you can try that for any set of numbers, and it should work and give you the correct answer as to whether or not that number is indeed prime. Excellent. So I hope your code looked something like this. If it didn't, that really doesn't matter too much as long as it works. And as I say, you can make this more efficient. My code does a lot of checking that it doesn't need to do. But I'm going to leave it like this for simplicity for the moment. And then in the next video, we'll incorporate this code into our app and allow the user to enter a number, and we'll tell the user whether or not it's prime.